Hello and welcome to Codified Lounge. My name is Gaurang and I am super excited to start this new series called Web Development Fundamentals. Now all the videos in this series are going to be beginner friendly, so if you have never coded before, don't worry, we are going to make sure we cover all the bases to help you launch your career in the field of web development. So without any further delays, let's get started. So before we jump into the details of web development, let's understand what is web development. What does it mean when I say I am a web developer? So web development is the area of software engineering that focuses on creating and maintaining websites or any other web apps. And it's a vast area which has many different specializations. So you could be in web development and focusing on website designing, where you would actually create designs on how the website should look, how the users will interact with these websites. Or you could be focusing on front-end development, where you could be actually just creating the websites and making sure they are usable and testing them. Or you could be focusing on back-end development, where you would manage and maintain the web servers on which these websites are hosted. Or you could be a combination of this. There are roles of full stack developers where you would be working on front-end technology, making the websites, and also back-end technology, maintaining the web servers and hosting the websites. So it's a combination of all these. So in order to become a better web developer, we need to understand how web works. And for that, we need to understand how internet works. What is internet, right? So in its simplest form, internet is nothing but a network of computers. Hundreds of thousands of computers around the world connected in a network, communicating with each other and sending messages to each other. And how is this network created? Right? So to understand that, let's go to the drawing board. So let's say we have two computers, right? Computer 1, computer 2. Let's say we have these two computers and we want to communicate with each other. How do we do that? Well, let's say we connect them using a cable. Now these two computers are connected, they can send messages to each other and they can communicate like LAN cable, right? So in order to do that, we added one port on each computer, right? And we added one cable. Let's say this network is awesome. Two computer network is amazing and it's working well. And let's say we decided to add one more computer. So we have computer number 1, computer number 2, computer number 3, right? We already have these two connected. So, okay, simple enough. We added third computer, we added two more cables. So now we have 2 ports per computer and we have total of 3 cables. Awesome, this works fine. The computers are communicating, we can play games, everything. Let's say this became very famous. Let's say now someone came in and said, hey, we need to add 10 computers in this network. We need a network of 10 computers and we are going to play Call of Duty on LAN over here. How would you do that? So let's draw it out. Let's say this is computer number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We are going to number them. Awesome. So now let's start connecting these computers. So I'm going to use a different color here and say amazing rainbow color connections we have here, and this is computer number 1 getting connected to all these 10 computers. So this is computer number 1 connected to all these 10 computers. I should have selected this instead of this because it's a two-way connection. Same way, let's say computer number 2, right, getting connected to all these computers, everything except computer number 1 because we already connected that. Same way, computer number 3, we need to have cables running from 3 to all these computers, right? Looks beautiful but not scalable. Why is this not scalable? So let's see, for this to work, for 10 computer network, we added 9 ports in each computer. And then how many cables do we need to do this? So let's say for computer number 1 to connect to all the rest of the 9 computers, we needed 9 cables. For computer number 2 to connect to rest of the cables, we needed 8, right? Because 2 is already connected to 1 with 1. Similarly, for computer number 3, we needed 7, 6, ... right? So this is like the sum of first 10 numbers. So n into n plus 1 by 2. So this is 9 into 10 by 2, 90 by 2, 45. So we needed 45 cables to do this. So just think, if we try to scale this to, let's say, 100 computers, it's going to be 100 plus 101 by 2, so 200, like 100 some cables, and it's going to be messy. It's not at all scalable. So how do we scale this? How do we create a network where we can add more computers easily? And plus 99 ports is also not possible in a computer, right? We have our limitations there. So one way to do that is add a new computer to this, a different kind of computer. So let's say we have our network. So we added I should have addressed on it. So let's say we have 1, 2, 3, 4, 5 computers over here, and 6, 7, 8, 9, 10. We have all 10 computers from our network here. Yeah, now we are going to add a different kind of computer over here. Yeah, let's name it computer number 11. So what this computer does, it has just one job. Its job is to receive messages from computer and then forward it to the right computer. So let's say 1 wants to send a message to 6. So what would 1 do? It would send a message to this guy saying that I want to send a message to, this is the message to computer number 6. So this guy knows where computer number 6 is. So it will take the message, forward it to 6. That's easy. Let's say 2 wants to send a message to computer number 5. So it sends message and 5. So again, this guy will take that message, send it to 5. Right? So what this basically does is, it's taking a message and routing it to the correct computer. And that's why this computer is called a router. All router does is, it takes the message, looks at the address where we want to send the message, and forwards it to the right computer. So it makes all these connections for us. And this is awesome. Now, in order to do this, we didn't have to add more ports. Each computer has one port, and for the 10 computers we need 10 cables. Okay, easy, manageable, one port, one cable per computer. This is amazing. All of them are connected to the router and it just works. This is awesome. Now we can easily scale this to more computers by adding more routers. So let's do that. Let's create a network of 20 computers. So we have this 1, 2 dot dot dot, let's say 10. Right? Just imagine there are 10 computers here. We have our router, we'll name it 11. We have another router, let's number it 12, and this router is also connected to 10 computers. So all these are connected to their respective routers, right? So now let's say we want to again send a message from 1 to let's say computer number 10. So 1 says, hey, I want to send a message to 12.10. See this? This is now the address of a new computer, right? So now the router knows this router number 11. It can debug, hey, 12 is this guy. So it sends this message to computer number 12, and the 12 knows, hey, computer number 10 is this guy. So it forwards the message over here. Same way, if 2 wants to send a message to computer number 10, it can say, hey, I want to send this message to 11.10, right? So it receives here. Again our router says, hey, I know 11, that's me, and 10 is here, so it forwards the message over here. Same way, let's say computer number 2, this guy, wants to send a message to computer number 2, this guy. What does it say? Okay, send a message to 11.2, right? So it sends this router is smart, it knows, hey, 11 is this guy, send a message here, and send the message to computer number 2 in that. This is perfect, right? So now the router has one job, the computer can send messages, and then we can keep scaling it by adding more routers to it, right? So we can add 2 more routers, right? And these routers can also be connected to other routers and so on. And one thing to notice here is, if you see this guy, if you see this address format we have over here, 12.10, it kind of looks like IP address. If you, I'm sure you might have heard of IP addresses, right? If you read, IP addresses are like 192.168.0.1, right? And we can cover IP address in more detail over here. It's out of scope. It's more related to networking. But basically, IP addresses is a unique identifier of a computer. So these routers can then identify a computer by its IP address. So it's a similar mechanism where when we send a message, we also send the IP address. Say, hey, send this message to this particular IP address, and the router knows exactly where to send it. Awesome, perfect. So this works. This works when we have the computers and routers in the same network, and we can easily connect cables to them. But what about cases where we want to send messages to computers overseas? How do we do that? How do we send? We cannot have cables from, let's say, Vancouver to Toronto, right? It's too long of a cable. Or let's say from Vancouver to India, right? So how do we do that? So in order to do that, like all the smart engineers, they came up with a amazing way. So they saw that, hey, we already have these telephone lines around connected to each and every home. Why don't we take advantage of that? Why don't we send our data to these telephone lines? But how would we do that? Telephone lines don't understand computer language. Okay, so we are going to create a new computer that will translate this language for them. So let's do that. So let's say we have this network of our computer, right? These guys are connected to a router, right? And let's say we added a new computer to the mix. So these guys are connected here, and yeah, this router is connected to this. So what this computer does is it converts the data coming in from our computer to the data that is understood by the telephone lines. So the incoming data is this and outgoing data is this. Here the color represents what what component understands this language. So if it's blue, then telephone line understands. If it's black, then computers understand, right? So what is this particular computer called? This is nothing but a modem, right? This is what a modem does. It takes the data from our computers, converts it into a language that phone lines understand, and then pass it forward. So that's what this modem will do. It will pass this info outside in its network of lines, and on the other hand, there will be another modem which will which will then be connected to another computer, right? So this is how we'll pass the info from one place to another. But now what happens here, right? Between two modems, how is this info passed on between two modems? Let's zoom out more. So let's say we have our computer, now we have our router, now we have our modem. Next, let's do this fancy one. Then comes the main thing, the ISP. The ISP stands for Internet Service Provider, right? So basically this ISP is nothing but companies that give you internet connection. So if you just Google local ISPs in my area, you will come across names, and those names will be very familiar. Most of them will be like telephone companies. And what these ISPs have is they again have this network of routers, right? So all these ISPs have very powerful routers in them, right? Which can talk to routers of other ISP. So what happens is, after the data is converted to what these phone lines understand, they pass on to ISPs, and then from ISPs it goes from a router to router. And these routers are like far bigger than our routers we use at home, and they are far more powerful, but more or less their job is same: to get the data from a computer, look at the address, and pass it on to the next computer in the address, right? So they go from a router to router, and then finally they come to a new destination modem, or it might go to a server. We're going to cover that next, but that's how it works. That's how this whole internet is designed, and that's how these computers communicate with each other. So we talked about computer connection, but how does web work, right? What happens when you type in a URL in the browser? What happens when you go to a website? So let's start with more basics. So let's first understand the URL, right? If you see, generally, this is a question mark by the way. Generally, this is how any of these URLs would look, right? So let's understand this. What's happening here? So first of all, let's start with this. What is HTTPS? So HTTPS, basically the first part of the URL, it defines a protocol. So HTTPS, or it could be HTTP without this, it stands for Hypertext Transfer Protocol. And what this does is it tells the browser on how to communicate with the server, which protocol to use, which set of rules to use to communicate with the server, right? Next part, www. This is subdomain. So when the web was first discovered or first started or invented, www was the subdomain indicating that this particular resource is a part of World Wide Web. But nowadays, we know everything is part of World Wide Web. So you can have different subdomains. That you can have, let's say, if you have a private personal website, it could be blogs.gorang.com, which says, hey, this URL will go to the blog section of my site. You could have resume dot something, right? So that is the subdomain. So the second one, the example is the domain name. Basically, a domain name uniquely identifies a server in the internet. It uniquely identifies a server or a service in the internet, right? And finally, .com. .com is the top level domain of the website. So depending on what kind of website it is, this domain could be .edu, .gov for government sites, .in, .uk for like country specific sites. But together, the whole thing, this defines like a unique, it points to a unique website or a unique server in the internet. The next part, my account, is the path of the resource. So and you'll see next in many examples that in some case the resources are very specific, like an image file. In that case, this path would point to maybe a directory structure in the server. In some cases where it doesn't point to a specific path, it could be resolved dynamically on the server itself. So in some cases, the server looks at my account and says, okay, now let's resolve this depending on what the user is asking. And that's where this comes into picture, ID. Anything after a question mark is known as query param. So the query parameter is used by the server to run some kind of logic on the request that you made and then return the response to you. Okay. So this is like a general understanding of a URL. Now what happens when you type this URL on a browser? So let's say this is you sitting on a computer, and I don't need to name it now. And let's say you went to this URL that we saw here, right? www.example.com. So what happens? So the first thing that your browser does, by the way, browser is your Chrome, your Internet Explorer, your Firefox, anything like that, right? So let's say this box represents your browser, or rather, let's say this circle represents your browser, because most of the browser symbols are circular, right? Firefox, Safari, Chrome, everything. So let's say this is your browser. So first thing that the browser does is it makes a request to the DNS server. So what a DNS is, it's domain name system, right? So what a DNS does is it basically takes the domain name. In this case, it says domain is, let's say, example.com, right? And it returns an IP address. So now you'll be able to connect the dots on why we went through this history of creating networks, right? Because as a human, we don't remember IP address, so we need a domain name to easily remember that. But in order for data to traverse across the internet, we need IP address. So that's what this DNS does. It returns the IP address to the browser, right? Now the browser takes the IP address and sends the request. Let's say This is just a random IP address. Let's say it made this request. And what happens is this request goes through multiple routers like we discussed earlier, multiple ISPs, and then finally reaches the web server. Right? It finally reaches the web server. So now the web server has server-side logic which looks, hey, this guy is asking for certain things. So let me respond. So it responds with some data. So now let's clarify something, right? In this case, this is the web server and what we are making the request. So we are the client. The whole web ecosystem works in this client server mechanism where a client makes a request to the server. In some cases, there might be another server where the server might be making a request, right? So in that case, our web server becomes a client and this server becomes the server. So the client makes a request to the server returns the response. And this response gets rendered on our browser as a web page. Now, what does this response consist of? So in most of the websites, I'm saying most because there are some exceptions, but in most of the websites, this response can have code files which are HTML, JavaScript, and CSS. Right? So HTML stands for Hypertext Markup Language, JavaScript, and CSS. CSS stands for Cascading Style Sheets. So basically, these three files combined together make your web page. Right? Whatever you see is a combination of these files. Along with that, so these are our code files. Along with that, in the response, we might also get some assets. I don't know how to spell assets. So we also get some assets. And what could this be? This could be image files that you might render, like your logos, your pictures. It could be video files, right? It could be fonts, right? Icons, PDF, or just data. Sometimes you might see a web page with, let's say, scores of players and their ranks and everything, right? So in that case, along with player info, there's also some data that the server sends to the client and the client renders the data. So it can be a combination of all these things, right? So that's how the web works, right? So when you say you are into web development, then you are mostly handling this part. You will be working on mostly the part where the client makes the request and the server sends the response. So when I say you are working as a front-end engineer, you might be working on this part of the response, all the code files, how to create those, how to design those, how to make them performant, right? If you are a back-end engineer, then you might be working on this logic to determine which files to send, any business logic that you might have, right? If you are a designer, then you might be designing this website. So that's the basic general introduction to how web works, what is internet, and what is to be a web development. So let's quickly summarize what we did so far, right? First of all, internet is nothing but a network of computers. Hundreds of thousands of computers connected with each other, communicating with each other through routers. Next, websites follow a client-server mechanism where client sends a request to the server and the server sends a response back to the client. The server normally responds in code files and or assets, right? Your code files are HTML, JavaScript, CSS. Your assets are images, fonts, video files, MP3, PDF, text, data, anything other than code files basically. And like I said, the server response, the code files that servers send are normally HTML, which stands for Hypertext Markup Language, CSS, which stands for Cascading Style Sheets, and JS, which is JavaScript files. And that's what we are going to cover next. In the next section, we are going to start with HTML. It's going to be a brief introduction to HTML. How do we create HTML pages, and how do we structure the page, and what are the HTML elements. After that, we'll cover CSS and finally JavaScript. So I hope you enjoyed the video. I really hope you learned something. I'll see you in the next video. And if there was anything that wasn't clear, or if you have any questions related to what we discussed today, don't forget to comment. I will try and read all the comments and try and answer all the questions that I can. And if there are any feedback on how should I improve the video quality, or how much detail should I cover, any kind of feedback that you have for me, please don't hesitate to again leave a comment. I'll try and make my videos better going forward. So I hope this was fun for you as much as it was for me, and I'll see you in the next video. Till then, adios, take care and stay safe.